There is a specific frequency we associate with spring, a low, constant hum. It is the sound of the world's most efficient agricultural worker. It is not expected to stop. But if it did, we often think of pollination as a natural, wild process. But in modern agriculture, it is an industry. The western honeybee, Apis mellifera, is a managed livestock species, just like cattle or poultry. Every year, billions of these bees are loaded onto flatbed trucks and driven across continents, from the almond groves of California to the apple orchards of Washington state. They are responsible for pollinating nearly 1/3 of the food we eat by volume, but more importantly, they underpin the diversity of our diet. Fruits, nuts and vegetables, cereal crops like wheat, rice and corn are wind-pollinated. They do not need bees, so calories would remain, but nutrients would not. Honeybee populations are currently volatile but managed. Beekeepers split hives to replace losses from parasites like Varroa destructor, pesticides, and habitat loss. While local collapses happen, a global simultaneous extinction is statistically unlikely under current models. However, genetic bottlenecks make the species vulnerable. A novel, highly virulent pathogen could theoretically sweep through the managed population rapidly due to the migratory nature of industrial beekeeping. For this scenario, we assume a perfect storm pathogen, a virus with a long incubation period, allowing it to spread undetected across borders via trade and migratory routes, followed by a 100% mortality rate for the Apis mellifera species specifically. It spreads through contact in commercial hives. Within one season, the managed global population collapses. The immediate effect is silence. In the Central Valley of California, millions of acres of almond trees bloom. Usually, this event requires 2 million hives, more than half of all honeybees in the US. Without them, the flowers open, wait, and fade. The petals fall without fertilization. There is no famine yet. The supermarkets are full of last year's harvest, but in the fields, the cycle has been broken. As summer arrives, the deficit becomes visible on the trees. Some crops, like apples and blueberries, produce fruit that is small, misshapen, or scarce. Farmers who rely on leased hives face immediate bankruptcy. In Brazil, the melon harvest in the northeast collapses. In Europe, the production of oilseed rape, canola, drops significantly, impacting cooking oil supplies. Wild pollinators, bumblebees, solitary bees, flies try to fill the gap, but they cannot replace the sheer density of industrial hives. You cannot put wild bees on a truck and drive them to a monoculture desert. This is the secondary effect most people miss. Bees pollinate alfalfa, lucerne. Alfalfa is a primary high-protein feed for dairy cattle. Without cheap alfalfa seed, the cost of feeding cows rises sharply. Milk, butter, and cheese prices spike globally. The crisis moves from the produce aisle to the dairy aisle. Meat prices follow as feed costs increase for all livestock. We would not starve in terms of calories, we would starve in terms of vitamins. The availability of vitamin A, iron, and folate would drop drastically globally. Deficiency diseases rarely seen in developed nations could re-emerge in vulnerable populations. Countries that export high-value crops, Chile, New Zealand, USA, lose billions in GDP. Coffee prices become volatile, while Arabica is self-pollinating. Bees increase yields and quality significantly. Robusta relies more heavily on cross-pollination. Plants that depend solely on Apis mellifera begin a slow march toward local extinction. Invasive weeds that don't need bees might take over edges of farmland. What scientists debate is the resilience capacity. Could native pollinators bounce back? Some models suggest that without the competition of billions of honeybees, native species, like the blue orchard bee, might boom. Technological solutions, robotic drones or pollen sprays, exist in labs but are unscalable for millions of hectares. We don't know how quickly the ecosystem would rebalance or if it would simply simplify. We built a food system that stands on the legs of a single insect species. It is efficient, it is productive, and it is fragile. The bee does not know it carries the weight of the global economy. It is just looking for nectar. Stability is often invisible until it changes. What if it did?